All right, Matthew from Drawboard. So as part of the work that we're doing, so for those of you that don't know what Drawboard does, Google Docs for PDF for architecture, engineering, and construction. So the big blueprints that you'll have all come across, instead of printing them out and marking them up, putting them up to flinging them up to the cloud and then real-time collaborating across them. So that kind of drawing that you can see there. So as part of the upload of these documents, the problem statement that we had is, if you see in the bottom right-hand corner of that document there, you've got a block of information. We needed to work out a way of extracting the information that's in that block of the image in a way that the users don't really have to have any involvement. So one of our users has got a project with 15,000 of these engineering drawings, and they want a seamless way to upload them into the cloud and not have to have any user interaction to achieve that. So that was the problem. So to go about solving that, there was a few routes that we could take. There's certain things like ABI, optical character recognition, that we could have used. Kind of an old player in the market, we would have had to stand it up in the cloud, host our own instance, and the pricing on that. These drawings are A0, that's 16 times A4, and their pricing is per A4 sheet. And it was so cost prohibitive that our break-even point on a per user basis would have been about 10 months, and that was terrible. So we needed an alternative solution. So that got me looking at Azure Vision and Google Vision at the same time, Google API Vision. So this is kind of our product here. I won't dwell on it too much, it's called Bullclip. But if you see these coloured sections here, it's kind of a cookie cutter approach that we've taken. So you draw a section on the image and you say, right, there's some data in this image that I'm interested in, and it's in these regions. And then if you look to I think your left-hand side there, you'll see there's drawing title, drawing number, and revision number. So the users said, right, the drawing title in this set of drawings is always going to be in this position. So these drawings are always the same, and the revision, the drawing number in the bottom right there is always going to be in this position, and the revision is always going to be in this position. So you can kind of assume that out of those 15,000 drawings that are uploaded, that information is always going to be in that position. So now what we needed was a mechanism to take that information, take the page of the drawing, and extract that information from it. So that's where the idea of word maps comes in. So we take the drawing, which is an image file, we throw it up to a vision system that then gives us feedback as to where all of the words on the page are. It gives us regions, and then based on the regions of those word maps, we can map it to the template of cookie cutter, just like putting a cookie cutter over the top, and then it will give us the information that we need to then associate with that drawing in those positions. So to do that, first explored Azure Vision to achieve that. So I'll take you through some results in each of these areas from Azure Vision, and the data that it gives you back in the API. So Azure Vision it's really easy if you've got an Azure account. How many people use Microsoft Azure here? Yeah, so you can does anybody use Azure Vision? So you can pretty much just go up there, get a subscription key, and start communicating with the service. Interestingly enough, something that we've just found out from talking to somebody from Microsoft, it says if you're using it for commercial purposes, they guarantee the security and integrity of all of the data on every single service that they've got, apart from Azure Vision. So we've got this with engineering and construction companies, confidential documents. If we were to use their service, they don't guarantee that information is secure. So that's a separate consideration to take into account. They are working on being able to provide that, but it's not there at the moment. So in Azure Vision, you can do the image analysis, and that's the kind of the marketing and the things that you've seen at Build when they said, how old is this person, its face, and all the big showbiz stuff that Microsoft do, and also work out key colors in an image, what the image is, like associate descriptions, categories, and tags with the image. So work out what's in that image and extract meaningful content. So we will start using that ourselves in things such as these engineering drawings, when there's a defect, somebody might take a photograph and upload that to the cloud, and then you want to automatically add tags to that image so you can serve up the data, and just like a search across a library of photographs, for instance. Handwriting recognition, so path data, you can send it up there and it'll try and interpret what it is. Probably not best for doctor's handwriting, probably wouldn't be able to interpret that. Don't think you can interpret it with your eyes, never mind OCR. And then there's a few other services that they've got in preview at the moment. So emotional recognition, what that is this, it'll give you feedback such as, I haven't done a deep dive into these three, but emotional recognition will give you feedback into what somebody's feeling. And this guy's sad, he's happy, this woman's crying, that kind of thing. Custom vision recognition, which I'll dig into later in the future things that we're going to do. But that's kind of machine learning where you can train the engine on what you're looking for. So in our case, which I'll cover later, we've got symbology in the drawings. I'll show you quickly. You see those cloudy figures and things? There's certain symbols that are standard across engineering drawings. So we might want the ability to identify those within the image. So we'll dig into that. And video analysis, I think they did a build this year where you've got, I think it was like a children's sports team, and they're running around and they've annotated on top of it, so you can actually, it's frame by frame at the moment. You can send the frames up and it'll analyse track where things are in the environment as it moves through. So let's have a quick look at that. So it's really simple to knock this up. It only took me an hour or something. So OCR, just to remind you what the OCR is. That there's kind of the typical block that we've got in that bottom right hand section of the drawing. So that is image, and we just need to extract the data from that. So if the demo gods are with me, can you read that text? Better. So what it's given me back is, you can see here project 4215, and it's given me the bounding boxes of the regions on that page. So if you think back to that word map that I showed there with the red boxes, that's effectively what it's given me. It's saying these words are in these regions. You can configure it to give you the characters if you want to be, if you want to dig right down to the characters of the words, and then it'll give you line breaks as well. So you can more accurately extract that content. We didn't need that for our purposes, but so all the way down, project 4215 Crescent Street, Queens, New York City, general notes, site plan, blah blah blah. The most important thing for us in here is that drawing number. So if you look at this, A-00I.00, so it wasn't an I, it's a 1. So for us that accuracy there, that mismatch is, and because it doesn't give us like a rating, a confidence rating on how accurate that data is, it's very difficult for us to automatically trust it to upload content to then classify it correctly with the drawing numbers. Disclaimer, we are actually using Azure Vision in production at the moment because it was various reasons, but it was one of the quickest things to stand up. So we have had to put a manual step in to our upload process, which is something that we don't want to have to do, so that the user verifies that. So let's have a look at the Microsoft logo. So that's the Microsoft logo there. So I've uploaded that to the image recognition. This is a trick that somebody from Microsoft told me to do. So that's going to give you the dominant colours in that, which it thinks is just white. It's particularly bad with the Microsoft logo. And then it thinks it's a drawing of a face, and it's 0.44% confidence, so it's not very accurate. I think everyone can agree it's definitely not a face.
Definitely adult content that you don't want to show Microsoft logos.
And then I thought, right, I'll have a bit of a play around with that facial thing. So I've got a picture of Tom Cruise. I mean, I've got a theory that Tom Cruise is the same age. Well, he's aged about 10 years in the last 40. So I think I currently look older than Tom Cruise. He's 55. I'm 36. So in the Top Gun era, it's going to do a bit of a scan on Tom. Yeah, adult. So it's Tom Cruise. Congratulations, it's worked out. And then you've got some really weird things going on there. It's person, outdoor, yeah, all that stuff. And then for some reason it says a woman and a cell phone. I don't think he's got a cell phone in that picture. Tom Cruise smiling for the camera, so that's pretty accurate. He's always smiling for the camera. I guess any picture of Tom Cruise you could put smiling for the camera on there. Age 26. There is a second mill in that photograph. If you didn't see, he's in the background there. So it has picked him up as well. Yeah, so that's pretty accurate. So let's have a look at Tom Cruise as he stands today. He does look, admittedly, a bit older there, but not 55. So that's picked him out. I won't go through the rest of it, but it's picked him out at 36. So apparently me and Tom Cruise are the same age. And again...
Have you tried your own picture?
No. I don't even want to. I don't want to know the results. For like 100 or something.
The interesting thing is that if you look at the previous one, the confidence was 90 something, 92, 93, and now the confidence is 97. So probably it's basing.
Sorry, is it?
It uses a baseline current photos or something like that.
93.
Yeah, 0.93.
That was the caption.
Yeah,
like,
yeah.
what's he doing? Yeah.
Yeah.
Does it change if you don't call the file Tom Cruise?
Did I call it Tom Cruise? I don't think so. Did I? I'm not sending the file. Though. I'm sending just the raw byte data here. I'm not sending it. You can send the byte data in the body of a post request, or just for speed, I did that. But you can send a link. You could send a URL to wherever it resides, which could have been called Tom Cruise. So, good question. So the last thing is a landmark. A bit pixelated, but that's clearly the Sydney Opera House. There's a boat there in the foreground and bits and pieces. Let's sum that up. So it picked the ship out. It's picked the fact that it's a dock and there's a harbour and all that kind of stuff. It's not racy content. But it hasn't picked the fact that it's the Sydney Opera House.
Is it supposed to? Is that why some of they advertise around recognising landmarks?
They haven't advertised it, no, not exclusively. So yeah, I'll show you the code there a bit.
Yeah, I don't think that it would recognize before.
It's pretty simple. The main bulk of the code's in here. I'm just getting some URIs there, some base URIs to send. The request parameters here, so visual features, category. I'm just saying what visual features I'm going to look for. The key colors, the tags with descriptions, the categories, if it's an adult image or not. The type of the image, I've included the faces there, and because it was Tom Cruise and I was looking for celebrities, I just gave it a clue and said it's probably a celebrity. So I did that for the Tom Cruise faces. The second one, I did it without faces and few of the bits and pieces. Because if if you do give it with faces for Microsoft logo, it'll give you all sorts of other information that you're not really interested. And then it's just a simple request. You're just going to put a bunch of stuff into a client call and post it off, and it'll give you the JSON back, which I was just displaying there. Cool.
Is it returning as a JSON string?
Yeah, it's a JSON string. I just put something in there just to format it so we could see it. All right. So Google Vision, not much of a different story really. They've got image analysis. With the Google Vision stuff, as I'll show you, you've got to kind of know what you're looking for. So you don't, if you want to limit the information, you don't just throw it up. However, you can say, I'm looking for everything, and then it will give you everything back. So if you know that you're looking for a landmark, you can say, hey, this is probably a landmark, and it will look at it for that. And if you know if it's face and stuff and a logo. And the interesting thing there is the web entity recognition. So you could throw an image up and it'll give you URLs of where it's got similar images matched to it, which could be fairly useful depending on what you're building. Not very useful for us, but I can see its use elsewhere. So let's run Google. So same images as before. So we're going to look at OCR of that block. It is noticeably slower. So I won't go through the whole thing here. But it gives us the language, and it's given us the vertices of the bounding box, top left, bottom left, top right. But the most important thing, so you can contrast it against the other, is that. So it's picked that out accurately. It's given me the right numbers. So we've got a decent confidence because I've run a lot of these text blocks through that it does pick that up about 99% of the time. So that's reasonable for us. However, it doesn't give you the confidence on that, which would be nice if it did.
Would it be feasible to use both as a cross-check against each other and only prompt the user if they disagree?
We could, yeah. It's just double the, well, I'll get to the cost in a bit, but it would just cost you a bit more. But it's quite minimal with this service, whereas you're probably talking about $1,000. So yeah, we could double that cost. $2,000 for 15,000 drawings is pretty reasonable. So yeah.
It's giving you the combined text there. Does the Microsoft one do that?
Yes, yeah, it does at the bottom, yeah. So the logo. So I have told the Google API that it's probably a logo, but it's given me the fact that it is a logo and that it's Microsoft Corporation, so it's accurate. The face, can't remember which one I gave it. It's a picture of Tom Cruise. So one interesting thing about Google, which you might not think is the case, is they do not believe in giving you the name of anybody when you give them the face. So they won't, I'm sure they're capable of it and they do it in the back end, but they don't serve that information up to you, so it's not going to tell me it's Tom Cruise. Doesn't matter what I do, but it's picking out his features and it's telling me where his features are, so it's telling me the eyes and the mouth and his eyebrows and all sorts of other stuff. So midpoint between his eyes, nose tip, so it's getting really deep diving into that face and telling me what's where.
So really good for an angle.
Yeah.
Yeah, it's reporting set. How's it doing that?
So it's working out where the where it sits back in the image as well. And then you've got angles of the camera, and it's already given you the emotions for that face there, which is what Azure have got in preview, but this is just part of what you get back. So, is he ever sad? Very unlikely. Headwear likelihood. So I'll skip the image properties. That's just going to give me back the key colors, the RGB components. I mean, I'll go through it quickly, but it's not much point in spending any time on that. So red, green, and blue components of the image, the key colors. I don't see where you would get use for that. But. So landmark recognition. It's telling me it's the Sydney Opera House, and it gives me a latitude and longitude. Pretty good.
So latitude and longitude of the camera position or the
Sydney Opera
landmark?
House.
Sorry?
It's where the Sydney Opera House is, yeah. In the world, so I could pinpoint that image on a map.
But you're not allowed to use Google to launch news in their terms and conditions.
Racy content. Spoof medical violence adult. Label, so what I passed into the label, I'll have a look in a sec. Yeah, so that's the Microsoft logo going into the label there. It's telling me it's a logo and it's graphic design and blah blah blah. Sorts of other things. And then the last thing, which is crop. So that's gonna, if you throw an image up, it's gonna tell you the best regions to crop the image to get the content that you want. If I press the button. Yeah. Cool. So the code's actually a bit cleaner here because you can use the same. So all I'm doing is giving it a type, image recognition type there. This is the code. Formatting a JSON, bit of JSON to put in a post body to send up to the API. That's it, and everything runs through this one method. Very clean. And as I said, you can send. In my example, I've sent one of these at a time, but you can send them all if you want, and it will give you back all of that content if you just want to do one request. So let's look at the pricing, the thing that's important to businesses. So 500,000 conversions. Google is $748.50, and Azure is $1,200. So that's quite a bit of saving for Google. And then just touching on stuff that we're going to do in the future. So I spoke about it before. We've got all these symbols there that we need some kind of training. Now you can do that with Google as well, but you've got to go to a lot more depth. You've got to stand up your own project in Google Cloud, and then you've got to intercept the image, and you've got to have your own storage. So you've got to have your entire solution up there to do that, which is fine. But obviously it's going to cost you money to put that up, maintain it. And then the trickiest area is to explain to big business why you've got their data in Azure and Google. So that's probably a key differentiator for us. Whereas in Azure, I haven't done any investigation into it, but you can theoretically keep it inside their ecosystem and do that machine learning component inside their ecosystem. Auto population of hyperlinks. So on our engineering drawings, we have reference to like Word documents and stuff like that. So the ability to go through, identify that's a hyperlink, lay a hyperlink over the top of it, so when they've uploaded their drawing, they can just click on it and it opens the document. It's pretty cool. And image tagging, so images such as this one in the bottom right there saying, yeah, it's a building site, it's most likely the survey site, and putting it in the image catalog and tagging that so you can actually search through it. Yeah, so that's it. At the moment we're hiring for 3 positions. I'll let you read that: Cloud, iOS, and UWP. And there's some really nice links there into the machine learning, and that TED talk here is particularly interesting. It's about how they changed the way that so if you think of an Abbey OCR solution, it's based off an open source project that the code's like 15, 20, 25 years old, and in the last 5 years they've revolutionized the way that they look at images, to the point where this I don't know whether any of you have seen this talk, but the guy, he puts a solution on this stage where he's walking around the stage and it's following him, and it's got a 60-second lag to where he turns it on the crowd and it's real time, like it's identifying everybody in the crowd and what they are, and he throws some fluffy toys on. It's like, yeah, it's a fluffy toy and blah blah blah. So yeah, cool. Any questions?
You're pulling fields out of the document there. how are you sort of correlating between the coordinates in the document that you actually want? Is that really dependent on saying, I expect the bounding box to be here? How did you really go from that?
How do we correlate it?
Yeah.
I'll just skip back a bit. So there's obviously a coordinate issue, so we have to do a bit of math to translate the coordinates. But the key to it is that the user's saying, so these drawings are all the same, like the blocks and the titles and everything are always in the same place, apart from when they're not. But you've got to kind of detect that they're not, and it's not a word, so or an image, a drawing number. But we've got to do that. We've got to get to that. We haven't done that yet. So the user's like, this is where this piece of data is. This is where this is. This is where that is. And then we say that that bounding box is the drawing title, and then we can just look up. Then we use the cookie cutter approach here, and then we map up what that is, just with like a dictionary, effectively dictionary to this piece of data. And then when they say, give me the drawing title for this drawing, we can just fling it back pretty quick.
Did you look to see whether there are any offline solutions for this? Because OCR's been around for ages.
Yeah, so I mean, Abby's the most, probably the best. So I did stand an instance of Abby up. For our specific needs, it needed to be a certain, it's like the fine reader engine or something. We stood that up.
I'll be fine.
So you can, their cloud doesn't support it, but the server that you could stand up has an engineering drawing setting, which does pick the information out. But the without that setting, the information that comes back is pretty bad, and it was at least 10 times the cost.
Okay.
And it was per A4 sheet, and we deal with A0, which is 16 A4s. So 10 times the cost times 16, and it just made it just unusable.
So what percentage of the documents that you got failed or would not resolve through this process? And what did you do with them?
So it's very small percentage, and it's usually documents that have been rotated. So you know when people, everyone's done it, scan something into a scanner, and an image has been that way around, and you've manually corrected it and rotated it. So the way PDF works is it is like that, but it's putting a flag on it that says it's been rotated with the rotation angle. When that happens, the coordinate systems can get slightly off, which means that this doesn't work that well. In terms of percentages, 1 to 2%, and then we just throw an error and say we haven't actually been feeding that information back to the user yet, but we're logging it, and we can see it. So the intention is, so this happens when we upload the document to the cloud. What we would do, and the user publishes it. When they publish it, we just return an error and say, hey, publishing's failed. Or perhaps have a separate tab where they can look at things that have failed, so they can then retry, and then self-correct. So say we haven't been able to get this data, do you want to just enter it manually and then upload it? That's the plan.
Does this work natively with PDF, or do you have to turn it into an image format first?
Yeah, I turn it into an image. For natively PDF, just trying to think. So the Abby Cloud SDK does work natively with PDF. So you can just send a URL to a PDF across. These work with images.
So is your tool batch processing thing or one at a time?
Batch. So these, when I said 15,000 drawings, they're uploaded in PDF format, and sometimes they're 50 pages, but it's 50 drawings, each on a separate page. So we have a workflow that splits each page out and then sends it in batch to our backend service, which just executes. It's effectively a queue, and we just pick items and we scale out, and we pick as many items off as we can, and then throw it up. And the Azure Vision API, which we're using in production at the moment, we've never had any problems with it. It's fine.
You said there was some user intervention to correct
the drawing numbers, because if you look at them, they're not actually. Let me try and find it. This was the one in question. It's alphanumeric, so sometimes it makes a 1 and I, and you can't do that because there's no standard convention to the number. They're called all sorts of things.
Does it have that kind of, just in general, configurability of the OCR?
Also, you can say it's a number, not in Azure Vision.
But
You could, I guess you could take the data and say, is this a number? Is this numeric? Are the numeric entities? You could get that. You could do that yourself when you get it back, but you can't give it influence and say, hey, this is most likely a number. Treat it as if it is a number and give me the number back. At least I haven't seen any way to do that. Unless it's machine learning, of course, and then you can train it.
Yeah, and you didn't play around with that yet?
Not yet.
You said that's
Yeah, that's next. Yeah. That's the next talk.